The focus of this lesson is on combining functions, in particular whether you're adding or subtracting functions. And we are going to do an example with subtraction. So if you see f minus g of x, ultimately what that means is you can rewrite that as f of x minus g of x. Even though the notation looks different, they're ultimately the same. And so you can take whatever function f of x is, which in this case is, I'm just going to kind of put it in brackets, it's x squared minus 4. And then you want to subtract off g of x, and then I would also put that in brackets. It's x squared minus 6x plus 8. And the good thing about putting the brackets or parentheses there, you can use parentheses too, just some sort of grouping symbol, is that you can see that you have this minus that needs to distribute on every term in that second function. So this is x squared minus 4, and again, if it helps, you can think of it as a negative 1 times each of these three terms. But it's going to change all their signs to opposite. So it goes minus x squared plus 6x minus 8. And then go ahead and simplify by combining like terms. So x squared minus x squared goes away. You have your 6x piece, and then you have negative 4 minus 8, which is negative 12. So f minus g of x at the end of the day is 6x minus 12. Then if you're needing to find the domain of f minus g, it ultimately boils down to, you could look at this function and kind of see it, but it boils down to the domain of f intersected with the domain of g. So we need to figure out what is the domain of f, and then what is the domain of g, and then we can do the intersection of the two, and that'll be our domain of f minus g. So the domain of f, well, f of x is x squared minus 4, which is just a polynomial or quadratic, and no matter what input you pick, if you square it and then subtract 4, you will get a real number output back. So every real number works. So that's your domain of f. For g, the same thing. You have g of x equals a quadratic, x squared minus 6x plus 8. And no matter what, if you square and then you multiply by a negative 6 and combine and then add 8, you're still getting a real number back. So because any polynomial, you'll always get real numbers for the domain. So the intersection of those two, the domain of f and the domain of g, is our domain of f minus g, which is what we're trying to figure out. But all real numbers intersected with all real numbers is still all real numbers. So you could write it like that, or you could write it like negative infinity to infinity if you're using interval notation.